Alright, ladies and gentlemen, so today we are going to starting with binary search. So our new topic, we just completed our linked list playlist is almost complete. Just few questions are left, like the medium one. So we will do them later on. But right now, let us start binary search, and we will do binary search tree. So this video is all about binary search. So ladies and gentlemen, let's start. Let's just see what the definition of binary search is. So let's just move to the computer. Alright, ladies and gentlemen. So now let's just talk about what is binary tree is. What is the binary tree? So let's just see the first definition. The definition saying a binary tree is a tree data structure in which each node has at most two children, which are referred to as the left child and the right child. Okay, so let's just see what it's saying. It's saying like it has an each node, like in each node. So I just draw a root node. Okay, it can has either two children. It cannot be has one. It can be has either two or zero. Max to max two. Okay, so you see this has two children. This one is let's say left children and this is right children. Okay, all right. So let me now you will say, okay, what if I draw two children over here as well? So yes, so you see this node has zero children. That's perfect. And this one has only two children. This node has two children left or right. Okay, so that's our binary tree is okay. So now, ladies and gentlemen, let's just talk about like what kind of binary tree do we have. We have something like full tree. So let's talk about what is full tree. A full tree is a tree which has every node has either zero or two children. So as per I show you over there, a full tree is that which can has either two. So you see this has two children, this has zero, this one has zero, this one has zero, this one has zero, this has two, this has two. So it means this is a full tree. This is a full tree. Okay, so that's the simple definition. Now let's talk about what is complete tree. What is a complete tree? So a complete tree, a binary tree in which every level expect possibility the last is full and all nodes in the last levels are as far as possible. Okay, so what this definition is? This definition saying a complete tree, that tree which is completed from the top to the bottom and from the left to the right. Okay, so what it means, if you look at over here, it's complete from the top to the bottom, it's complete from the top to the down. Okay, and it's from the left to the right as well. So you see it's going from left to the right, so it has nodes over here as well. So what if I draw something like over here as well, let me like this. So this is not a complete tree. This is now not a complete tree. So the complete tree is only possible if it is completed from the top to the bottom and left to the right. Okay, that's the complete tree. Okay, so the final tree we have is perfect binary tree. So what is perfect tree? The perfect tree is a binary tree in which all interior nodes has two children and all the leaves have the same depth. So what is saying? It's saying if you check it by level, so it is completed from level by level. So you see every node has two children and the downward the bottom one has no one has any children. Okay, so they are all they all have zero children. Okay, so a perfect tree is that tree which is a complete tree and a full tree as well, that we call a perfect binary tree. So ladies and gentlemen, I hope so this will give you a good understanding what the binary tree is, why we are like how can we face the binary tree in our questions. Okay, so ladies and gentlemen, now let's talk about like how to traverse a binary tree. So to traverse a binary tree, there are like three methods to do it, which is let me just take you to that page, which is pre-order, in order, and post order. All right, so now you ask like what is pre, in, and post. So pre, in, post means like we have node, left tree and right subtree. Okay, so what it means, like we are first of all visiting the node in pre. Just understand and just look at over here, just focus on these colors, don't look at the order one. Okay, don't look at the order one, just focus on pre, in, post. So you're gonna like you're gonna remember this thing. So in means like in between them, in between the left subtree and the right subtree, we have to visit the node. Okay, so it's in between them. What is the post? Post means like after the left and right, after visiting the left subtree and the right subtree, we have to now visit the node. In the pre, again, what we have to do, we have to first visit the node, then we have to go left and right. Pre means like you see the first, pre means first of all we are visiting the node. In means like in the between, in between of what, left subtree and right subtree, we are visiting the node. In the post just means like just after the left subtree and the right subtree, you are visiting the node. Okay, so let me just give you a more brief clear example. So to just do it, let's talk about pre-order one. So we are just talking about over here pre-order on this one. Okay, so we are on this one. All right, so let's say I'm traveling, let me just change the color. Let's say I'm traveling left right, node left right. Okay, so we are traveling like this and we get an output over here. So the output means give us the result like in which node we just have traverse. Okay, So in this condition, you see we are first of all visiting the node. We are first of all visiting the node. So what will happen? I will get in my output one. So you can do it either using stack or array list, anything you want to do. Okay, it's all up to you. Okay, so what I'm doing, I'm just putting one in my stack initially. Then what happening now? I will travel my, after doing this, I will travel its I will travel its left. So I'm just traveling its left. Okay, so what will happen now? Now I come on this one. So again I have to do node left right. So first of all I will visit its node, so I will put it over here. Then I have to go for its left one, so I'm going for its left tree. So I will go for its left tree. Then now come over here, again we have node left right. So again I will visit the node first, so I will output my 5 over here, and then I will simply go for its left one. So it doesn't have any left tree. So what I will do, I will just simply erase it over here. Now it's about right one, so we just traverse it because it doesn't have right as well. So we just simply come back from over here. We just simply come back from over here. Okay, like this. We just simply come back over here from over here. Now we are on this one. So on this tree, we just traverse the left tree. We just traverse its left subtree. Now we have to traverse its right one. So for that one, what I will do, let me just circle it, and we are going its right. So now I come over here. So I have to print its node left right. So I first of all visit its node. I print over here. Alright, in general. So I have to distinguish sometimes what I'm doing. Now I erase it from over here. Now I have to go for its left. So for its left, what I will do, it doesn't have any left, so I will just simply erase it. I just simply say like come back out from then I'm going on the right, so it doesn't have right as well. So what will happen, I just simply end up from over here, and I will go back over here. Okay, so we just did it like this. All right, like this, we are just going like this. Okay, now we come over here on this one. So what happened, we just travel our second right subtree as well. So I will remove my R from over here. Okay, now I will go back up to over here. Okay, so it's this main root tree, we just main root node, we just traverse its left. Now it's time to traverse its right, so we are traversing its right. All right, now we're going its right. Okay, so what will happen, first of all our job is to visit node and then go to the left subtree and right subtree. So what will happen, I will output my 3 over here. Then I will go check for it, does it has left. It will say no, I don't have left. So what will happen, I will simply come back. Then I will check, it has right subtree. If it says no, it doesn't have right subtree, I will simply come back like this again. Okay, so by doing this, I will come back over here on my first one. So once I come back over here, then it means like I just traverse its right subtree as well. So I just completely traverse my traverse my complete tree. Okay, using pre-order. So in the output you see we got something like this over here. All right, ladies and gentlemen. So now let us talk about what is how the in order will work. All right, ladies and gentlemen. So we are now going to our in order. So let me just take this arrow from over here to over here. Okay, so we are now going over on our in order. So what will happen? We have to first of all visit the left subtree, then visit the node, then visit the right subtree. Okay. So how it will go? First of all, I will go its left. So I will traverse its left. I will come over here. Again in this one, I will traverse its left. I come over here. Okay. Again in this one, I will go for its left, but it does not have any left. So what will happen? I will come back. Now I have to visit its node. You know the NVM, so I have to visit its node. So what will happen? I will output my 5 from over here, and I just visit its node. Now I have to visit its right. So it does not have any right. So what will happen? I will simply come back from over here as well. Okay. So we just completed this one. Now I come back over here. Now I come back on my 2. So let me just draw something like this. Now I come back on my 2. So what will happen? Now I just traverse my second left subtree. Now I have to visit its node. So its node will give me 2 over here in my output. Okay. So after visiting its node, then I have to visit its right subtree. So what will happen? I just go on its right subtree. So again in this one, I have to check its left node or right. So in this one, it doesn't have any left. So I will just simply come back. I have to visit its node. So I will output over here, and I have to visit right as well. So it does not have any right as well. So I will just simply go back over here. Okay. After doing this, what it means, like we just traverse our second node right as well. So now we are going back upside over here. After doing this, what will happen? I traverse my main root node left subtree. Now I have to visit its node. So what will happen? I will output its node over here in my output. Okay, I will print. I just print its node over here. Okay, now what I have to do, I just simply go for its right one. I will simply go for its right subtree. Alright, I hope so this thing makes some sense to you what I'm doing. So similarly, I will check for its left node or right. So in the left one, what I will do, I will just simply say it doesn't have any left, just come back. Then I will go for its I will visit its node, and I will print its node over here, and I will say like now go for its right, but it doesn't have any right, so I will just come back from over here as well, and I will simply go back on to its one. So after coming back to the one, so it means I just traverse my one left left node and right, so I just traverse it completely. So I just completely traverse my in order, and we go the output something like this. All right, ladies and gentlemen, so that's how we traverse in order. Okay, so now let's talk about like how we traverse in post order. All right, ladies and gentlemen, so now we are traversing our post order. So what will happen in this one? In this one, I have to first of all visit its left. So what I will do, I will first of all visit its left. So I will come back over here, come over here. Okay, now in this one similarly I have to visit its left as well. So I just come over here, I have to visit its left. It doesn't have any left, so I will just simply come back. I will simply come back, and now I have to go for its right, but it does not have any right as well, so I will simply come back. Now I have to visit its node, then I will simply output its node over here, which is 5. So we are again doing something like this. I just output its node, which is 5. Okay, all right. So now in this one I have to visit its right. So what I will do, I will just simply go it over here. Now I have to do same thing, left right node. This thing doesn't have any left, so it will come back. This node doesn't have any right children, so I will just simply come back. Now I am on its node, so I have to visit it, and I will simply print it in my output. Okay, so like this. So after doing this, I will just go back to my parent node. Okay, so this is the parent node in this one, and like the 2 is a parent node of its children. So let's say 5 and 6 are children, so it means like the 2 is parents. Okay, so now in this one, what it means, like we just traverse is left one, so we also traverse this right one as well. So like I forgot to erase it. We just traverse the left over here. Now we traverse the right as well. Now we have to print its node, so I will simply print its node. So my mistake, I forgot to erase it. Okay, now I come back over here on my first one, on its parent one. So I just completely traverse its left one. Okay, now what I have to do, I have to go for its right. I will go for its right one. So I will come back over, come over here. Now I have to do the same thing, left right node. Okay, so it doesn't have any left, so I will simply come back. It doesn't have any right, so I will just simply come back. Now I have to visit its node. I will simply print its node over here. Okay, and after doing this, I will just go back to its parents node. Okay, on the one. All right, so now I am on the one. So what just happened? So I just visit its right one as well. Okay, now I have to visit its node. I have to visit its node, so which is 1. After doing this, I just completely traverse my post order. Yeah, I just completely traverse my binary tree using post order traversal. Okay, so ladies and gentlemen, I hope so this thing is like how we are traversing and using pre-order, in order, and post order. So that's all the main concept is. So I hope so this thing is like very critically like what we are doing over here. So if you still have any doubts, anything, just do let me know in the comment section. And I forgot to tell you the time complexity and of searching, insertion, and deletion. Okay, but in this one, the time complexity of searching we are dealing with is big of n. Why? Let's say I have to visit 5. So what I have to do, I have to traverse completely from top to the down to get to 5 over here. Okay, so big of n for the worst case. I'm saying, like in the time complexity we deal with the worst case. Now let's talk about what's the insertion. Let's say I have to add children to my 5. So what will happen? I have to again traverse from the top to down using, let's say we are traversing using breadth first traversal. Okay, so if you don't know, we will talk about them later on. Just thing like this. So in the breadth first, how we traverse it? We traverse level by level. So I have to traverse it level by level like this. Like let me just show it to you. We are just traversing something like 1 level, 2 level, 3 level. Now I will come over here to insert something. So in this one, the time complexity we are dealing with is big of n. Okay, big of n for the instrument. Let's say for the deletion as well. For the deletion, similarly, let's say I have to delete my node 5 from over here. Then again I have to traverse from the top to the down to delete this 5. So for the worst case, the time complexity is big of n in this one. So ladies and gentlemen, I hope so this thing is very clear, like how we are dealing with our time complexity in our binary tree. So these are the like just basic and like how can I say, like these are the one of the like basic concepts like to do this. And without any further ado, now we will start solving all of the questions from the Leetcode, the best easy questions, all of them we will cover it, and then we go for the medium one, and then finally we go for the harder one as well. So all right, ladies and gentlemen, so now final thing I just want to tell you is like you can find all of the playlist link in the description, and the questions links in the description as well. That one are the lead for best, easy, medium questions and hard questions, which I will suggest you, so that you can just check out all the links in the descriptions. Okay, so thank you ladies and gentlemen for watching this video. I will see you in the next one. Till then, take care, bye bye, and I love you guys. Believe me, I love you. Take care, bye bye.